Okay, so let's learn how to integrate functions like secant square or secant times tangent. Now the rule is very clear. If you integrate secant square, you get tangent. If you integrate secant times tangent, you get secant. Now how do we get them? Well, it's coming from calculus 1. I'm not going to do the procedure here. We don't often use this rule, but really it comes up in trigonometric integration. So if you know the rule, then you can use it right away. Okay, so to learn how we can get this tangent, how can we get tangent if you integrate secant square, well, we will do it in the future again. All right, so just for now, just remember the rule. Now here's one of the important rules. Look at what you get if you integrate 1 over x square plus a square. Now here the format of the function is very interesting. You have x square plus a constant square also. So you have to have that exact form, and when you have that, what you get is 1 over a times tangent inverse x over a. So let's do an example. Alright, so let's look at example 1. Well, we have a different example, don't we? It has nothing to do with rule 9 or 10. Okay, so this is coming from previous video. So if you have missed that previous video, click on the link that appears above to watch that video and learn how to integrate sine again. Okay, this one is a good example. I will show you why I picked this example. Now what can we do about 5, negative 5? Well, we can take that negative 5 out, right? So if you integrate sine pi x, what you get is negative 5 times, if you integrate sine, you get negative cosine pi x plus c. Now what can we do about pi? Okay, forget about pi. What do you do if you have 2 there? How do you integrate sine 2x? Well, you just divide by 2, right? 2 is a constant. But is pi a constant? Yes, pi is also a constant. So when you see pi, don't get panic, okay? It is also a constant. Treat it like a constant. So let's just divide by pi. So our answer will be negative, negative, positive here. So positive 5 cosine pi x over pi plus c. Okay. Alright. So let's go to example 2. Okay. So finally we have an example that we can use rule 10. Now let's compare. So we have x square plus 9 in the problem, and we want x square plus a square. So what is a? Is a 9? No, a is not 9, right? What is a? A is 3, because what is 9? 9 is 3 square. So we can rewrite this integral as 1 over x square plus 3 square. So the answer will be 1 over 3 tangent inverse x over 3 plus c. Okay. Alright, let's look at question 3. Now it's same question, similar type of question. So what is a in the question 3? It's 4, right? So 16 is 4 square. So you can use the similar procedure and get the answer. I will let you do that. Let's look at question 4, I'm sorry. So in question 4, we have a constant here, extra constant here, 3. What can we do about that 3? Well, you already know, right? We can take it out of the integral. So this is integrating 3 times 1 over x square plus 25. Now if you integrate this 3 times 25 is 5 square, right? So what you get is 3 times a is 5. So 3 times 1 over a according to the rule, right? So it's 3 over 5. 1 over a is 1 over 5. Tangent inverse x over 5 plus c. Okay, right. Let's do the 5th one. So this is a hard one. 5 over 2x square plus 9 to integrate. Now what can we do about 5? We all know what to do. So 1 over 2x square plus 9. Okay, now the problem is we have 2 here. How can we, so if you look at the rule, we just have 1 in the rule, right? Coefficient of x square is 1. So how can we make it 1? So that's important. How can we make it 1? How can we get rid of that 2? Well, we can take a 2 out of denominator. What do we get? So if we take a 2 out of denominator, 5 over 2, because taking 2 out of denominator is like taking half. 5 over 2 Okay, integrate 1 over x square plus 9 over 2, right? So that's the problem. We make the problem little bit ugly, right, when you take out the 2, but it is what it is. So now we have, because when you factor out 2, you have to have 9 over 2. Okay, you have to divide by 2. All right, now what is a? That's the question. Pause the video and think, what is a? Is it 3? No, it's little bit complicated than that. What is a? Can we write 9 over 2 as a square? Yes, it's 3 over square root 2 square, right? 3 over square root 2 times 3 over square root 2 is 3 over 3 times 3 is 9. Square root of 2 times square root of 2 is 2. Okay, yeah, so that's your a. What is a? 3 over square root of 2. So what is the answer? 5 over 2 times 1 over a. So here a is 3 over square root of 2 times tangent inverse x over a, which is 3 over square root of 2. Now this is a good question to practice your algebra skills also. So 5 over 2, here 1 over 3 over square root 2, we can write it, we can use the reciprocal of 3 over square root 2. So 1 over 3 over square root 2, we can multiply by the reciprocal, so it's square root of 2 over 3. Okay, tangent inverse, we can do the same here, so it's square root of 2x over 3 plus c. So we can simplify this problem furthermore. Square root 2 and 2 cancel out and leave a square root 2 on the bottom. So 5 over square root 2 times 3, tangent inverse, here you can't do anything, right? Okay, so this is the solution. Okay, it's a little bit tricky, but try to do this problem again and again. All right, okay, so then to watch my next video, click on the link that appears in this video, and I will see you in the next video. Bye bye. Thank you.